Good morning, students. Today we will be seeing in the fourth unit database management system, and one more topic, small topic, is data warehousing. These two topics we will be discussing in our today's video session. First, we will be discussing about database management system, and while talking about database management system, we should talk about what is actually database. So you people already you would have studied in your second semester about the management information system, the subject management information system, about this database and all. So with that introduction, we will start here. A database is an organized collection of data which can be used alone or combined related to other data for multiple purposes. So this is actually we will be seeing a particular database is an organized collection of data which will be used for either it will be used alone, or sometimes it will be used for even combined related to other data for multiple uses, or for multiple reasons, multiple purposes. We will be using the database which we are having, which we have collected already for our organization purpose. Depending upon the organization purpose, we will be collecting the data and we will be storing it as a database, which will be it is an organized collection of data, so that which can be used for either it will be used for a single purpose, or it will be used for any combined to related to other data for multiple purpose. And this one is actually our related topic, database management system. A DBMS is a collection of programs that enables to store, modify the modify and extract information from a database. That is what actually database, where it will be stored, and it can also be modified and extract information from a database. So that is actually DBMS concept, is where you'll be having a collection of programs to enable that enables to store, where we can store a huge amount, and we can also modify that what we are having, and also we can extract information from the database which we are having. And database refers to set of related data and the way it is structured or organized. So that is what here we'll be talking about here. So where it will be referring to the sets of related data and the way it is structured and how it is being organized. So how we are going to, which one will be the first thing we should do according to that system. Say for example, in hospital management, or in hospital consumer customer relationship management. So what is that structure we will be designing, and what should come first, and what should be in the order, like that we will be doing here in database, where proper structure we can give. And access to this data is usually provided by the database management system only. So where if you're having a lots of data, no, so access to that particular data, it will be provided only by the management system, that is database management system software which you are having, and it will be having an consisting of an integrated system of computer software that allows users to interact with one or more databases and provide access to all of the data contained in the database. So very best example is, so when you are taking a particular database of any particular hospital, so they'll be having multiple specialty hospitals, say for example if you're taking, and each and every patient details a particular organization, that is hospital, will be maintaining in that particular software, and it will be providing access for all the uh, persons who are all having authority to monitor it. So this particular software, DBMS software, it will be working out very easily, even though if you're having very good database, but to maintain, that is what, to maintain structure and organize it properly, and multiple persons, if you want to view and if you want to have any changes, so this DBMS will be providing a very big information at this present uh, conditions actually. So key characteristics of database management systems are their performance, and we can have a large volume of database, and we can also, that is what we the persons who are all administered, who are having the authority to administer the data, they can share the data, and it will be having securities, they can provide securities, and we can also avoid duplication. If any, we can easily remove the duplications and all, and we can also use, we can have multiple users but at the same time. So that is a very big advantage. So when you go for any work, no, so at that time you will be knowing about this last point which you are discussing, different users, but at the same time, say even 50 to 100 users, that itself is maximum in hospital sector I'm talking. Companies, if you're going, you can see multiple persons will be using, but for hospitals, this itself, if you're having if even 100 persons or if they are using it, still they can have it at the same time, they can access it. And one more thing, very important point is security. Only I told no authorized persons, if they know it is actually it is a very big security, and this is actually what is the purpose of database management system. Uh, Typical file processing system supported by conventional. So previously and all, actually there were many pictures I have removed where if you go to any government hospitals at present, okay, but previously I'm talking, if you go to any government hospitals, there will be at least 5 to 6 rooms which they will be maintaining file alone. That and all, it is being erased now. Okay, because of this particular system, database and database management concept systems, where only two systems is enough, and they'll be having the and according to the system storage, they'll be having the details of the patients in the two systems itself. And please go to, if you're not gone to any hospitals, please go to any government offices, and that too mainly taluk offices, and you can see how they have stored the files in one particular section. Now only they are using systems and all, but if you are asking before 30 years, 40 years document, you please go to that room, how they are maintaining it and how much space it is occupying. That and all we'll be seeing in coming slides, okay? And data duplication, that is what we were talking, no? Duplication and inconsistency can be avoided, and difficulty in accessing data. So if I'm asking any data, no, previously and all, people will search and they will be telling that please come after 1 hour or 2 hours. But now it is not. So people, if you go and tell that particular numbers, immediately they'll be taking your files. And third point, no, very important point, data isolation, where they can store multiple files and formats for each and every individual. So it cannot be isolating data much as possible, can keep malware from spreading and containing to one unit. That is the main thing, okay? And data integrity will be there for the assurance of accuracy and consistency of data over its entire life cycle. Okay, very big advantage, data integrity and all. So then atomicity of updates. So atomicity, that is what in computer science field they'll be talking about one concept called ACID. ACID means actually acronym of ACID is actually atomicity, consistency, isolation, and durability. This is very important of database transactions that intend to guarantee validity even in the event of errors. So it is a very big advantage where consistency, durability itself is there, means you can check how much somebody else will be telling, no, if you're posting any videos or if you're passing out any messages in electronic field, that it will be there at least for 35 to 40 years. So you cannot remove it. That much it will be spreading. Uh, that is an advantage for this particular database informations actually. And concurrent access, the by multiple users at the same time, and security, very good security will be there, so the no security problems will not be there, and very big so that we have seen purpose, and now we'll see advantages and disadvantages of DBMS. And it is full of independence, data independence will be there, uh, so that the use of the data for computing and presentation, it will be very much independent. So whatever the information we need, only we can extract that information and we can send it to somebody, and efficient data access will be there. So it can be making use of queries to access data from the database, and the integration will be there, that is ensuring that the data in the database is very accurate. So if you are entering any incorrect information, no, that and all, it will be rejected automatically, or it will be highlighting. So that is very big. When see this part and all, when you're talking theoretically, you might not understand. But when you go and work in this particular software, no, it will be showing. So if you are entering any wrong information, say for example, in the name column, if you are typing any number, it will be showing some error message. And if in the id column, if you are entering any other invalid items, no, it will be showing an error, so it will be automatically getting rejected. So it will not, we cannot go for the next step itself. So that and all, it is there in data integrity. And very good data administration will be there. So where because of that TBMS software, it will be maintaining, and it is very good manage, it will be manageable. Database administration is a function of managing, and also it will be maintaining database management system softwares and all. So concurrent, again and again we are talking about this point, concurrent access, the ability to gain admittance to a system or component by more than one user. So many concurrent access means many people can be can be many people can use the can access at the same time. And the crash recovery also is there. If anything is there, if any problem in system breakdown, we can easily recover it because of the particular software method is like that. And we can also control the redundancy. So it may not be repeated the same data in each of the storage system, so that wastage of storage space can be avoided, so that it can be, redundancy will not be, the same information will not be stored everywhere. So it will be showing that, and storage space can be used at an effective manner. So optimum use of storage we can use because of this one point, no, you're talking controlling redundancy. And every time we'll be talking about security, data security will be there if you're having this DBMS software. And that is reduced application development time. So normally when you're using any systematic or any particular system oriented uh, softwares, wherever you go, we can talk about the time consumption. So it will be very much less, and that is the main, wherever you go, this is the main point we'll be talking about. And also about control data inconsistency. So in this particular data, no, in a DBMS, all applications use the same set of centralized data. So if you're changing on one particular column, so automatically it will be doing in some other place also. That is what here control data inconsistency. So here if a change in data needs to be done only in one place, and the changes can be updated in all the application wherever you're using the database of that particular customer or any, depending upon the organization. If you're changing here, and automatically depending upon the DBMS software which you are using, same thing you can be, it will be viewed wherever this file is being stored, no, it will be changed automatically. That is a very big advantage. And why we should not go for DBMS always. So please underline the word always. So it is expensive, then complexity, then general purpose not suited for special purpose tasks and all. So where when we're talking about hospitals, for all hospital setup it will not be working out. Only the hospitals which we are having at least minimum of 30 beds. Minimum of 30 beds, if you are having this particular system, it will be working out. Or else to maintain that itself, it will be cost oriented, and also it will be complexity will be there. And these are all the well-known DBMS softwares which you people will be knowing better than me. So some people might be would have worked in this particular systems itself related to this particular software, and these are all types of DBMS where we'll be talking about hierarchical, network, relational, object. So hierarchical means you people will be knowing depending upon the hierarchical structure. Say for example, MD, say doctor will be there, and under him there will be specialist people will be there for each and every category. Say cardiologist will be there, then urologist will be there, nephrologist will be there, then skin related dermatologist will be there, then ophthalmologist will be there. So depending upon that hierarchy, we'll be seeing one by one. That is what I'm talking about. This is the model. This is a data model where the data is organized like a tree. So using parent-child relationships, we'll be talking about. So these are all when you're talking about theoretical point. Sometimes you may not be able to understand. So main advantage of this is in order to retrieve data from hierarchical database, the whole tree needs to be traversed. That is the main disadvantage of this particular model. So we'll see this. No, the next slide. This is actually hierarchical model. So where we can talk about. See here, they're talking about one example about where each student in school reports to a given department, and each department can be used as a parent record. So we can talk about that. So and according say we can change here itself. Okay, so this is actually where talking about root, that is the main source, and each root will be talking about each. Say when we're talking here, no need to take student, we'll talk about customers in hospital, that is patients. So and whatever uh, problems we can talk about, and they'll be sending to that concerned specialist to each and every uh, doctors here. That also we can talk about here. And next one is we talking about of uh, what is it? Network database model. So network database model. It was actually where we're talking about in the year 1960s. So where we'll be talking about it was there in the 1960s and all, this particular model, and later people were talking about. So wherever you go now, every year now we are having updations every 6 months. Previously and all, in from the year 1960s and all, compulsorily 5 years once they'll be having changes. It will not be like at present scenario. 5 years once or 7 years once or 10 years once there will be changes. So that like that only network database model has been arised where we'll be having lots of flexibility will be there. So only instead of allowing only one particular patient to have, this model allows each child to have multiple. That is, please don't mistake here. If you see the slide, you can understand. So where if you're going for any checkup, okay, you can meet all the specialist doctors. You should, but you should spend time for that particular and all. You should spend time, and you can meet all the specialists on that particular day if you're going for medical checkup. So these are all will be integrated. So related network related database model. Okay, so this is actually where it will be linked to every network. See, I'm not telling hospitals follow only this particular. Depending upon this, say for example, we'll be having only relational database design mostly in hospital because related to that particular whatever the customers, that is patients, they are coming for treatment. According to that, they'll be going for this particular database design. That is what your relational database design is. Depending upon the uh, problems, health related problems they are facing, they will be sending to that particular specialist doctors to that particular area. That is what your relationship database design. 90% or sorry 80 to 90% of the hospitals prefer only this particular design relationship, and this one is actually object oriented where most of that it will be there talking about engineering database and multimedia database, where if you want to explain to the patient about his health related issues, you can talk about multimedia wherever see uh, I'll tell lots of examples. One of my relative was having actually some problem, and when he went to one particular hospital, they told that you should do angioplasty. There is a block, and he told okay. He has consulted 2 or 3 doctors, and finally he has done angioplasty in one famous hospital in Chennai. So he has been admitted on Monday. Thursday he has got discharged, and while being discharged from the hospital, they have given a CD. What CD is? They have asked. Even I was there at that time. We asked what is a CD, and they told that this is the operation we have done for that particular patient, and we are giving it to you. So in future, even if you're not coming here, if you show to any particular specialist, they'll be able to understand by seeing this CD itself. So these are all a very big advantage now related to our this particular concepts and all PBMS, and this is actually the designs we are talking about, where it will be occupying minimum storage. That is what we were talking here, and also see I want to talk about one particular slide. Okay, no problem. Here we'll be talking about the database contains no unnecessary data will be there, uh, and it can be added and updated easily without causing any mistakes. And what is that requirement for database design is requirement analysis. What is it we require? And conceptual database and physical database. These are the 3 steps are needed actually. And requirement, actually we should find out what really the customer wants. That is actually requirement analysis. And according to that requirement, you should develop conceptual, defining the entities and attributes, need and the use we should find out, and the relationship between these. the entity relation model. According to that, we should design. And after implementing the conceptual design, use a Dbms system. That is what Dbms we should implement. So requirement analysis, actually first we should find out in steps in the what is requirement analysis. So what does really the consumer want, and next we should develop conceptual design according to the need of the customer, and we should have a physical database after developing the conceptual design. And this is actually the relationships, so where people will be having multiple many relations and many one and one-to-one relationship. So coming slide now, we'll be talking about hospital related. So this is what I was talking about. This particular slide, please go through this slide about a hospital database where they'll be talking about conceptual data model. Okay, so it will be there will be a team consisting of doctors and headed by doctors and who are all responsible, and they'll be the patient. If they want to provide treatment, they'll be going it, and the patient will be admitted by a ward, admitted in the ward, and the nurse, and what is it? The nurse will be supervising them, and what drug we should, the prescription, everything will be there in this particular system itself. This is what actually we'll be talking in these two slides about not only about hospitals, but also about pharmacy. These two things it is there in this database design. Okay, so I'll wait here for. Okay, if you want, you can push also. You can see, no problem. So, but my duty, no. So you can talk it in two ways. A doctor will be giving treatment to the patient, and if you want to be admitted in that particular ward, he'll be going there, or else he'll be giving only prescription and drug, and that he'll be supervised by if he is being admitted. So that is what you should understand. And this one is talking about pharmacy database. Okay, where you can talk about these things and all. It will be stored the middle box where you'll be talking about drug ID, then patient ID, physician ID, data time, everything will be there. And if you click one, and it will be going directly. If you're clicking physician ID, will be going there, and you will be having all the details about that particular physicians. Everything you can see in pharmacy. uh, If any this for this particular model or this particular design, I'm talking about the organized pharmacies. Not if you're going to any pharmacies at your place, you cannot go and talk about there. I'm talking about in hospitals, very big hospitals, they will be having this particular design in pharmacies also. And next topic is data warehouse, where actually there is only two slides here in this data warehouse. It is a stable, read-only database that combines information from separate systems into one easy to access location. So I think you can understand what is warehouse. So where huge amount of information will be stored at one particular place. So and it will be easily to access in that but from that particular location. This is what very easy to understand this slide. So data warehouse where all the informations will be stored. Say for example, when you're talking from a hospital sector point of view, we'll be having uh, doctors related information. They'll be having about nurses related information, patient related information, and they'll be having about what is the general information and what is the total beds we are having and which are all the vacancies very big thing it will be there in the data warehouse. I don't know how many of them uh, have gone to Tirupati. Booking a room in hills, that is in Tirumala, that itself is a very big see, when you are vacating the room, when you are staying in one block, and when you go on give that slip while vacating, you will be entering that this particular customer has vacated, and immediately it will be highlighting in that room allocation where it is away almost 3 or 4 kilometers away. These are all data warehouse concepts only. So where if you are able to understand practically this concept and all, you can understand. If you are looking for this one, these slides or this entire practical related subjects first time, sometimes people may not understand. So please go these subjects and all. When you enter into the hospital sector, you will be learning many things. Thank you, students. If any doubts, please call me. Thank you.